Let's go directly into the topic here, as promised. Last point, additional functions and tools. So this is a little bit more the relaxing part maybe. We have implemented a startup recorder for the motor protection. This is to record, of course, the startup phase of the motor. We can record currents, voltages, powers. This is what powers, I don't know. Binary signals like the breaker close command, status of the motor, standstill, starting, running. This is mainly what we has as a default setting for that. This is really configurable because this startup record is part of our standard slow scan recorder function, which is now available in the Siprotec 5 devices, in all Siprotec 5 devices now. Also in the 7SX800 in the latest version, this was also added and released here. This slow scan recorder is freely programmable, and yeah, you can visualize that, watch that with it has a standard COMTRADE format and an additional native format, and you can basically display this or visualize this with our CGRA program, which is part of the Dixie package, with a Siemens COMTRADE viewer, with a Siprotec 5 Web UI, web user interface, which we discuss a little bit later, or any other COMTRADE viewer, because it's a COMTRADE file basically. This is what we per default as a factory setting have assigned. We see here the slow scan recorder, and here is a column for the classical fault recorder. So here this we use for the motor start, because we trigger that with a close command of the circuit breaker. Also this can be discussed and changed. Here you see the TX. TX means the signal is registered, and the T means this is a trigger condition. Of course we can set anything as a trigger condition. Again, this slow scan recorder is highly freely programmable because it's a standard function we took over from our 7KE85, so the fault recorder device in the Siprotec 5 family. Modified it a little bit, and yeah, basically it was the motor protection who triggered this development, so that we now have also the slow scan. There's also continuous recorder and a trend recorder in all Siprotec 5 relays available now in the protection relays, just to mention that if you did not know that. And yeah, the reason why we did this was also triggered here for the motor protection, because we wanted to have this motor start record or log, basically, that we can register what happens during the motor start. These are the settings. What we register are not sampled measure values like a classical fault recorder. We have rather measured values which are calculated over a certain time period, and this is here this average time. So in my example here it's 10 cycles. That means 10 times 20 milliseconds, so every 200 milliseconds we make a measurement value and store this measurement value, so then this would be 5 per second. Okay, and yeah, the other settings you know already probably from the classical fault recorder, so I don't go here into detail. One thing is interesting, the estimated record number, the number of possible records. Here 224, so 224 motor startups. If we do this kind of setting, if we decrease here the post-trigger time to a smaller time than 1 minute, then we can increase the number of records, and then depends on the frequency, how far back this in time is, what you see in the relay. And this is how this motor start record looks like, or can look like. Also this can be configured here. I have here the 3 voltages and the 3 currents. So here we see just 2 voltages because I pushed this a little bit up on the screen, so that we see also here the binary signals. Again, if you want to see other things like the frequency, the measured frequency, or powers or whatever, you can just add this, and these traces will come additionally to what is configured now here, what I show here basically on that diagram here. Okay, next point, now we leave the device as such and go to some additional tools we have. The first one is the Siprotec 5 Web UI, the web user interface. And this is a built-in tool in the protection relays. It's always on board as a key feature because this is a server functionality which is in the protection relays. That means you need just an ordinary browser on your PC like the Chrome or Firefox or Microsoft Edge, and you connect your PC with a relay, and then you get this screen. So what you see here, for example, what we discuss later, this comes directly from the protection relay. So there is no additional cost, and everything comes from the protection relay. So you don't need to install an additional program. So this web user interface is practical. During commissioning, you get additional information. You have a quicker access to this and that, as if you use the Dixie program, for example. And if you don't have the Dixie, it's a good method to communicate with the relay. Instead of working on the front keypad, you can connect your PC and make a lot of settings and other movements with that built-in functionality here. So this is a little bit what we see here. I show you this in the next slides a little bit more in detail. Connection via encrypted protocol. So cybersecurity here is important, and we take that serious. So it's an encrypted protocol. We have encryption chip on the in the relay as such, and I'm not the cybersecurity expert if you ask them. So here we provide everything, and it's even possible to use the RBAC principle, role-based access control, instead of connection password if you like, and if you have set up this with the relays. Okay, so same story as with the Dixie. And we can use the standard web browser. So this is the landing page. We have basically here a field of tiles with the different topics here. And if we click on one tile, then we come into a submenu where we see also the related tiles. And in that way, we have the hierarchical structure where we can access all the interesting topics here. I just picked out a couple of them to give you an impression. This will be not a complete presentation of all the details. We have separate webinars about these additional tools around cProtect and the Dixie. I think one for each of these, so for the web UI, for the digital twin, for the cProtect tools program. So if you're interested in the details, please have a look and go there. Then you see more information about these tools. I just want to discuss a little bit, to talk a little bit about that. Okay, here I can see, for example, one of the displays of the relay. You see we have the motor, the circuit breaker is open. And what is interesting, alongside with this display, I can here create me a list of alarms. So signals which become red if they become active. Here I took the example, I took the digital twin at that time and made some motor starts, simulated some motor starts, and then I went over the restart inhibit temperature and put this here as an alarm signal here into that web UI. And you see this becomes now red because the breaker is open. So this restart inhibit signal becomes active, and it's active because I'm above the temperature. You see here the rotor temperature is just above the 66% or 67% here, 69%. So this is still active, and if the temperature falls below here this value, then this alarm drops off. So it gets a green color, and this green color then I can acknowledge. That means the color turns to a gray color like we see here for the other alarms or signals, and then I see, okay, there is this alarm and it's inactive, so I could acknowledge it here, and it's also registered in the relay. Next example is the settings page here, for example, for the thermal replica rotor. So I jump in via the tiles, and then I can make here my settings. I can then go via this menu here on the headline to other settings, either in the same function group or somewhere else. And then when I've finished all the settings, so I can go up and down all the time and make the settings in various screens here. And if I've finished my settings, then I can click on that button here. And this is then to download the settings into the relay here. Okay, next I can show measurements either in a table form where I see then here the voltages and the currents, face-to-face voltages, and the sequences are here shown, so positive, negative sequence and so on. And I can show also here my measured values as phases in this diagram, as you see here, the voltages and the currents, for example. Another functionality is to show the fault records of a relay. So I have a fault record in the relay because maybe there was a fault or certain trigger for this fault record. And then I can show this fault record here also on the screen using this Web UI functionality. I can zoom in and out and shift here the range what I want to see. It's a kind of first approach. So I can here have a first analysis of what I see. It is not that mighty as the SIGRA, and it's also not the intention to build in here all the functions we have with the SIGRA. So basically it's limited at the moment at least to the time signals. I don't have vector diagrams, for example, or other stuff, harmonics or so. I can show here the fault records, the classical fault records, and also the motor start log. As I already mentioned, they can be shown in the Web UI because it's a slow scan record, and I can also show you the slow scan records. So I can either visualize a fault record, which I select out of a list here. I can trigger a fault record, clicking on that button if I want to see the picture of a certain situation. And I can also download, of course, this fault record onto the PC so that it is stored, and you can then open it with the SIGRA if you are back in the office, for example, for closer analysis. Okay, so that's in a nutshell about the Web UI. There is a lot of more functionality, which I now skip just for time reasons. Then the cProtect tools. This is a standalone program, which is a portable program, so you don't need to install it even on the PC. You can run it from somewhere on the hard disk drive or even from a USB stick if you like. And here the focus is to give an additional program. So for people who don't have the Dixie, for example, this is a tool or collection of functions here, which I need, for example, when I install the relay. Cubicle wiring, for example, is supported. I have here hardware and wiring test. Also in that early stage, I can upload a configuration or upgrade the firmware, up and download the firmware of the relay. I can upgrade the device functionality. So these are the function points, which I can modify in the relay. So upgrade the relay function points number, for example. And now latest, I can also download the device the device data, and also the configuration. So it's logs, configurations, records, and so on. So we can say device data. So I can get this from the device and get it stored on the PC into a special file format. And this I can then use with a Dixie to make analysis or something like that. So a bundle of programs in this one small, tiny portable program. And very handy because you don't need a Dixie, and you're also independent of any firmware version in the relay. So this works with any firmware version of the relay here, this bundle of programs. Okay, here's an example how to load data into the relay. Here's the cProtect tools, and I can load data directly. So using maybe the front USB port or the rear port here, or I can do this also via a remote connection. It's just an Ethernet connection what I have here. So what can I download into the relay? On the one hand, a DAF file, so this describes the device functionality. Basically, it's the number of function points. Device driver, so a firmware version I can download into the relay, or also a certain configuration. If somebody has these cProtect tools and he gets the configuration from somebody else, which has the Dixie 5, then this person does not need a Dixie 5 to download the settings into the relay, just takes the file and uses the cProtect tools to download it into the relay. This program is free of charge. You can download it from the CEOS portal, or it's also part of the Dixie installation. If you have Dixie, then it comes also along with the Dixie. And yeah, you don't need to install it even on the PC. You can just go and use it for that purpose. I can get data from the relay here in the same way. So on the one hand, the process data, logs, fault records, and also the configuration in form of a so-called TCF file. Good. Now I have to speed up a little bit here. Again, okay, here is the screen where I see the hardware wiring. I can show the binary inputs which are activated, and I can activate the contacts, the binary outputs here by clicking here on these boxes, and then the relay contacts will close. So I can measure or can put a voltage on the cubicle terminals, and then I can see if the respective binary input, for example, here picks up or not. Then I know the wiring to the binary input is okay. And if I close here a contact, I can check with a continuity device here to see if the loop is closed. So beeper, and then I see, okay, the contacts on the terminals of the cubicle belong to this contact here if the status moves here. I can inject currents and voltages. I have here a phasor diagram again, and I can use this also multiple times. So each for a different relay, and then I can also check the interconnection between two relays. So I activate the contacts on one relay, clicking here somewhere on the contacts, and then I can have a look if these contacts activate the binary inputs of another relay. So I can also test here the wiring between devices here. Okay, and finally the digital twin. Also very short. Here we have a lot of material for the digital twin. It's a digital twin, a virtual copy of the relay software. So this is not any software, fun software running here. It's the exact software, the original software of the relays running here on a virtual basis in the cloud. And what you can do, you can test here your relay configuration by injecting voltage and currents. You can set binary inputs, for example, to see if the binary inputs are working fine here. You see then changes here, for example, in the position of the circuit breakers. You have additional tools here, like the web UI and so on, in the cloud. So you don't need to have them installed on your PC to work with the relay. You can use this for training purposes, because you can create any Ciprotec 5 device in a couple of minutes. If you have the Dixie 5, for example, you create this simulation file, and then you can start up any kind of relay, and this is really practical. There's a lot more to that. Just one more word. What I did also to create this slow scan recently, I had a fault record as a COMTRADE file, and I just used the COMTRADE replay functionality here of the digital twin. That means I loaded here this COMTRADE file. Here you see how this COMTRADE file looks. You can scroll here through the various channels or phases. And yeah, then you click here on this replay button, and then this COMTRADE file is replayed on the relay, and then you have the respective reactions with the relay. So this is another application. If you want to analyze a certain fault record and you want to play with the parameters, then you see immediately what is the effect here. Good, and many more. I would like to encourage you to go into the other webinars if you are interested in more details here. Finally, I would like to show you our application guide, which also came out recently. So this is a book with application and explanation about motor protection. I think it's like 83 pages here. You can download it here following this link in the PDF. You can get later, you can download later. Or also, I think we put this as an additional documentation into this webinar. And let me see if I still have this open here. No, this was the wrong one. Here it is. So this is the second part. So this is basically the index here. So we have here basics of the motor, synchronous, asynchronous motors, overview of the protection function, then the thermal functions, sensitive ground fault protection if you have an isolated or compensated network, a topic which I completely left out here, current transformer requirements, And then we have a couple of examples how to protect certain types of motor. So as a kind of guideline, a medium-size asynchronous motor, then a large asynchronous motor here, and a synchronous motor with the additional functions here. Last time I was asked about the Korndorfer starter method. This is described, for example, here in this high-power asynchronous motor, and much more so. Here you have also additional information if there are still questions left. I can just encourage you, go there and have a look into this motor application guide.